I'm going to be talking about GFLOWS, or finding long-term outback water solutions. It's really a research project by the Gorda Institute for Water Research, which has got a partnership with the three universities, CSIRO, ISWARM, SA Water and SARDI. But a key collaborator on this particular project has been the in-kind support from the Geological survey, so we're really appreciative of that. Really what I'm going to present here is not really my work, to be honest with you. It's some key collaborators, including Carmen, Krapf from the Geological survey, Mark Keppel is a colleague of mine at the Department for Environment and Water, but also the geophysics, which is an important component of this through CSIRO, Tim Munday and Camilla Soerensen, Associate Professor Andy Love from the Flinders University, and Simon Brown for the visuals. So I've heard magnetotellurics twice today, but that's not a word I'm going to be talking about. Are you going to be talking about that, Carmen? But one word you have to get used to is paleo, and it's not paleo diets, it's paleo valleys. I'm not Pete Evans, even though people mistake me for him, no. But an important matter is that regarding food, regarding economic development, whether that's cattle, whether that's the mining industry, water is a really important resource. When we're talking about mining and exploration, maybe it's not the first thing we think of, but it's certainly a really important one. And what we're going to be talking about today is this hidden water, or this paleo valley water. So let me just give you a bit of a view about where our study location is. It's in the APY Lands. It's a population of the Indigenous community of around 3,000 people. It's a 2-day drive from Adelaide, or you can fly to Alice Springs and drive 5 hours pretty much southwest. It's some of the oldest rocks consist of gneisses. We've got some granitic intrusions, doleritic dikes. It's tectonically active. You'll see a map that looks at the total magnetic intensity where there's some east-west structures. This is actually the highest ranges, the Musgrave Ranges in South Australia. Mount Woodruff is around about 1435 metres above sea level. And as you can see, our study site is just outside the community of Freegon. So this gives you a bit of a view on the ground. You can see the Musgrave Ranges in the background. Again, 1435 or 12 to 1300 metres above sea level. And on the plains, they sit at about 5 to 600. It's an arid environment, very low rainfall. So if we look at the typical well locations from our database, we can see they essentially follow the modern day creeks and obviously the roads for access. If I now look at yields greater than 1 litre a second, or I could look at greater than 2 litres a second, there's not really many wells that offer that. And again, they're really governed by those modern day creeks. So in 2016, a survey, electromagnetic survey was put together. The funding was over 1.5 million from DEM and DEW, and with a lot of help from the CSIRO. And as you can see there, that's the footprint that it covered. It was mainly for mineral exploration, but there was a thought that perhaps this could find some hidden water resources. So here's a bit of a view about what the output gives us with an AEM survey. Essentially, it gives us regional variability or conductivity across the area. We can obtain depth slices at regular intervals. And as you can see there, it depicts these Paleo Valley channels, the Lindsay West and the Lindsay East. And essentially this is what we're trying to go from a modern landscape, which we can see where the modern day creeks are, but we want to have a look and see whether we can detect this ancient landscape and look at these water resources under the cover. So we focus on 2 separate systems we used for this AEM survey in 2016. The one on the west was the Tempest system, the one on the east was the SkyTem system. And this gives you an output from the SkyTem survey. This is a depth slice of 50 to 60 metres below the surface. Resistive areas are blue, conductive areas are red. And as you can see, the Lindsay Paleo Valley here. If we go a bit deeper now, 90 to 100, Again, those reds aren't as prevalent, those conductive areas, so we might assume that that's getting to the base. Here's a bit of a cross-section of the system. So we've got the fractured rock system where the most grave ranges are in the north. We come down into the co-alluvial, alluvial aquifer system where a lot of the community water supplies are from. They're generally shallow, 20, 30, 40 metres deep. Very limited sort of resource, and then as you can see as we move along, we can see the Paleo Valley aquifer system, which is something we were trying to detect. Now the key is what is in these, what do these conductivity signatures mean? Is it a series of clays? Is there water in there? Is there no water? And that was really the essence of a drilling program to pretty much verify this particular Paleo Valley. So we centred on the Lindsay East Paleo Valley, which is around about 6 kilometres from the community of Freegon. This is obviously when you've got to get drill rigs and equipment in there and do some on-ground works, having proximity to a main road is really important. But also it was adjacent to the community and therefore their community supplies, which rely on the local groundwater. So effectively we had a lot of groundwater data to characterise the system. If we zoom in on that now, as you can see, there's Freegon, there's our first site, DH1A. I think Carmen will touch on site 22, but that was more to look at the groundwater characteristics in the shallow system. DH1A is, again, centred on the Paleo Valley. The approximate width, we thought from the AEM, was around about 1.5 kilometres, depth ranging from between 100 and 150. We called the centre of this. We also set up multiple wells in a configuration that would essentially be used for potential testing for not only environmental traces but also hydraulics. These are just some images from the drilling program that went from July to September, about 2 months. We did find water, and Carmen will share with us a little bit after I finish a little bit more about that. We found water pretty much from about 8 to 10 metres all the way down. We essentially think the Paleo Valley is around about 100 metres deep, and yields are looking at 10 or 15 litres a second, although we're still testing that water. And the other important factor is the salinity was under 1,000 parts, which is really good for obviously supply, but also perhaps agriculture. So what I'm going to do now to save this presentation is hand it over to my colleague Carmen. I guess some of the things that were talked about are some new conversations, and I guess this is the start of some of those new conversations with the Department for Environment and Water and the Geological Survey. So could I please present Carmen Krapf.
Thanks, Adrian. Yeah, I was really lucky to actually join into this program, and I'm also really proud that I brought the geology back to the hydrogeologists. So I'll talk you actually mainly through what we encountered with the drilling. Because with the AEM data now, we can manage actually these Paleo valleys. We now know where they are spatially. We know potentially how deep they are, but we don't really know what the composition of these Paleo valley fields is. And this is important for the groundwater itself, but I think it's also important for our geological understanding. South Australia generally has a really good understanding about the Paleo Valley systems and the Paleo drainage system, mainly driven from the Eucla Basin. And you can see that in these graphics, where we've got kind of good control based on drilling and long-term studies. However, in the APY Lands, it's a completely different story. We have some nice pictures put together by several authors that are conceptual models, but there is not a single drill hole that actually drills in and through the Paleo valleys that actually has a core. And only with core we actually get an idea what the composition of this Paleo valley is. So it was a little bit of a guess until now. So now we've got the AEM, we know where the Paleo valleys are, and we can start to think where do we want to drill and get the most out of it. So I proposed, in the name of the Geological Survey, to the GFLOWS program, why not actually get a drill core. It's really unusual to actually get drill core through cover, and I think this is now really one of the great opportunities to actually look in more detail what is really there. So I'll talk you through today through the first cored drill hole through a Paleo valley in the APY Lands. So I'm really excited about that, and I hope you are too when you see the rocks. And the rocks are actually lying out in the exhibition, and Adrian and I and our colleague Mark Keppel are really keen to talk you through. So come and see us at the booth at morning tea and lunchtime and afternoon tea. Adrian already said we use the AEM to actually target the location of the Paleo Valley. I put on your left-hand side the regolith map because, you know, this is always the first map we should start with, and we have a good data set here in South Australia. I think one thing I really want to take you home from that point is like, well, the current drainage system is actually displaced to the ancient Paleo system by about 3 to 4 kilometers to the west, which also reflects a bit of tectonic activity throughout the tertiary, or actually throughout a really long geological time, including the tertiary in this part of the world. And we also see there's a general east-west structural trend in the Musgrave. This is not really picked up by the center of the Paleo Valley we see to the right-hand side, but actually by the tributary systems. So there's also lots of structural information in this AEM data set we haven't even tapped into yet. The drill core, our talk today, we actually collected 2 drill holes, but one through the main Paleo Valley, the Lindsay East Paleo Valley, is DH1A. We drilled to an end depth of 117 meter, but we only could core to 93.4 meters. And already what you can see on your right-hand side is the little stratigraphic log with the interpretation of the deposition environment we encountered and the AEM data. So the AEM data shows us actually a really nice kind of layer cake stratigraphy, and when we actually then look at the drill core, this kind of is repeated. But for the first time, we actually have a geological backup of AEM data. So we have this really large AEM data set where we don't actually, again, didn't have any core control of the cover, but now we can actually see, yes, the AEM data works really well because it imaged actually quite good, at least the main units that are encountered in the Paleo Valley fields in this part of the Musgraves. So let me talk you through the core. We start at the base as sedimentologists. We actually go the way the sediments are deposited. We didn't drill into the weathered basement. We didn't core into the weathered basement, but we actually received chipped samples, drill chip samples from there, and we're quite confident to pick up the contact between the weathered basement and the overlying Paleo Valley fill. At the base of the Paleo Valley, we have actually fluvial deposits. They're generally quite fine-grained and moderately to well-sorted, which is quite unusual because if you think in other places, we actually expect in this fluvial system quite coarse-grained and gravelly deposits. That's generally not the case throughout the whole core, and you can look at that, as I said, at our booth. But that's also a result of the weathering of the rocks we have. They're outcropping. We have the gneisses and mainly the granites. If they weather, we get the saprolite and we get clay and quartz grains, and they are not really large in size. And so whatever you fill into your Paleo Valley and deposit there will actually reflect your catchment area and your local geology around there. So at the base we have weathered Paleo Valley deposits, fluvial deposits that are in some parts really highly cemented. If you move up the stratigraphy, we get this really high conductivity zone on the AEM, the purple zone. This reflects actually a shift from a fluvial system into a lacustrine system. So also reflecting a paleoclimate change where we move from a fluvial into more like wetter climate where actually a lake system could actually fill up these Paleo Valley systems. And the resultant deposit, what we have is a dark muds, and towards the top there, about 15 meters of mud deposits, lacustrine mud deposits that are towards the top are getting a bit more oxidized. And in the center of it, we actually have the record of a drying out phase because we have about a 1 meter thick gypsum horizon that represents actually the drying out during this lacustrine phase in the Paleo Valley. Moving up, we're going to younger fluvial deposits, overlying these lacustrine deposits. Again, we have this kind of medium-grained, moderately well-sorted sandstones that are overprint by calcite cementation. In some parts, we have really running sands where they're not cemented at all. In other places, they're really tight, but developed a secondary porosity, which is actually good for the groundwater storing. And then we're slowly moving out of the Paleo Valley, and we're going into nearly the modern day environment, even if we're 30 meters at depth, where we start getting we're filling actually up the Paleo Valley, so this ancient erosional form, and we're moving more into these wide sand plain deposits, which are overprinted by pedogenic calcrete. And these are the wide areas we see here in the core. And then on top, again, also really exciting, I don't think you see very often in your geological career that you actually have a diamond drilled sand plain with an underlying calcrete. This is your chance to see it. So the modern day deposits again reflect really what's in the upper part of the top 30 meters of this paleo channel. Now, having these drill cores and also drill chips from several areas around the Lindsay East paleo channel, we can actually put together a more defined model because this program just happened recently. So this is the first draft of one of these 3D block models of the Paleo Valley fields. We, at the moment, don't have any stratigraphic control on it, but on Monday, together with our colleague Liana Stoyan, we actually took sample for palynology from these lacustrine fascies of the Paleo Valley field and hopefully get some data out. I know that people talk about two phases of Paleo Valley deposits from other parts of South Australia. We can't actually yet confirm if this is also the case here in the Musgraves. But overall, you know, for me it was more about the geology, getting this information about the cover, but the general program in GFLOW really concentrates on finding groundwater resources in these remote communities. And again, I focus on the drill site or drill hole area 1, where we actually, by drilling through this center of the Paleo Valley, we encountered 3 main aquifers. One at the shallow phreatic water table, so from 7 meters onward we actually hit the water. Then we have a second zone with really good high yields in the interlayered sandstone layer and claystone layer as part of that younger Paleo Valley fill. And then we have got a fractured rock aquifer in the underlying weathered basement underlying the Paleo Valley system. Overall, the water quality is quite good. We have salinities below 1,000, so they're good for drinking water. And that's quite different to the current community water they're using up in these areas. And we also have really high flow rates. Adrian showed you before that most of the wells only have flow rates about 1 or 2 liters. We hit 5 to about 20 liters. So, you know, really good story for the communities there and further developments too. So to sum everything up, the AEM proved really essential to actually find the valleys in the first place, but also to find the relationship between structures and sediments. However, the drilling was necessary to actually help to verify the geological interpretation of the AEM data. We now know how these paleo valleys are compartmentalized and how thick the fill are, and we can actually take that back into the interpretation of the AEM data. And this will actually be the focus of Tim Munday's and Camilla Soerensen work from CSIRO. The drilling program was also successful in identifying these water-bearing zones and hence the groundwater for the area up there. And also, by drilling through into the basement, we can now better understand or pick the basement Paleo Valley contact in the AEM data. To finish off, this work can be upscaled to the large data set we have for the APY Lands, and hopefully links to more findings of groundwater sources for the local communities there and for future developments. Thank you.